Okay then, after understanding the concepts of distance, displacement, velocity, speed, acceleration, we need to now look at the graphs of kinematics. And the first types of graphs that we need to be concerned about are distance versus time graphs or displacement versus time graph. And this is going to be the focus of this video. So with displacement time graphs, there is a single rule that you need to just remember. And that rule is that the gradient of the graph equals velocity, equals speed or velocity. If the graph is a distance time graph, then what you are finding is speed. If the graph is a displacement time graph, then what you're finding is velocity. Now then, we know that speed does not have direction and it's distance over time, so the gradient of the graph is actually giving us the speed. And since velocity is displacement over time, that is what we are finding from displacement time graphs. But before we even look at some actual graphs, we need to know how to find the gradient of some graphs. So let me draw a graph which has some quantity y and x on its axis, and the graph has a straight line shape. Now how do you find the gradient of this graph? Well, the first thing that you need to do is pick 2 points on the graphs, any 2 points. Ideally they should be as far away as possible. And then what you're going to do is you are going to draw a triangle like this. So this becomes a right angle triangle basically. Now what we actually want to do is call this point x1 comma y1 and call this point x2 comma y2. So that is the first point and that is the second point. Now the change in the quantity y is basically called the rise. That is the change in the quantity y, and you can find this by subtracting y2 and y1. And the change in the quantity x, which is going to be time in our case, is called the run, which is called the change in the quantity of x, and that is x2 minus x1. And your gradient is found by rise over run. Now the rise is change in the quantity y, the run is change in the quantity x, so it's found by y2 minus y1 over x2 minus x1, and that is how you find the gradient of the graph. Now let's look at some examples of graphs and see what can we deduce from the graph about its gradient. So I have this line. What can I say about the gradient of this line 1? I can say that the line is straight, therefore the gradient is constant. It's not a changing gradient. The line has the same slope from the start to the end. Let's look at another graph. What about this line 2? Well, this line also has a constant gradient because it's a straight line, but you can see that it's much less steeper. So the gradient is actually less than the gradient compared to the first graph. What about this one? Line 3. Well, this line also has a constant gradient, but this time the gradient is negative. When you find out the gradient using the formula written above, y2 minus y1 over x2 minus x1, what you're going to find is that you get a negative value. So that means this has a negative gradient. There could be other examples as well, so let's look at them as well. So what if you find a line like this? This is actually not a line, this is a curve. So you can see that the slope or the gradient of this line is always changing. And how is it changing? It is actually increasing all the time. In the beginning of the line, if you pay attention to this part and then you pay attention to this part, what you will realize is that the part later in the graph is actually steeper than the first part. So the gradient of the graph is always increasing. What about this one? Number 5. Well, the gradient here is always decreasing because the initial part of the graph is steep, whereas the later part of the graph is much flat, it's much shallower. So now we understand what gradient is. We can actually look at some graphs, and here's some data in the table, and what it shows us is that a car actually is at 20 meters from some starting point. So let me just draw our car. This is the car, which is at 20 meters from the starting point, and the car stays there all the time. So at 0 the car is at 20, at 1 the car is at 20, at 3, 2, 4, 5, all the time the car is at the same point. So we can conclude from this graph that this gradient is actually 0. The gradient of the line in this graph is 0, or you can also see that the displacement is not changing. So how could you describe the movement of this car? Well, we can say that velocity is 0, or in other words, this means that car is at rest, or another word for it is stationary. The car is not moving at all, and there is nothing much else to be said about this graph. This is quite self-explanatory. So let's look at another situation. Now with this data, the points are already plotted on the graphs, and you can see that steadily the displacement is increasing. The car starts here at the starting point and then moves in the positive direction, and the graph will actually be a straight line. Now the gradient of a straight line is constant. The gradient is constant, so we can conclude that velocity is constant. We can also say that the gradient is positive, which means that velocity is positive. So remember, it's not the values on the y-axis which are actually telling us whether the car is moving forward or backward. It's the direction in which the line is going as the time increases, which tells us in which direction the car is moving. So it's the gradient sign. If you find out the gradient of this graph, you'll find out that it's a positive value. So velocity is positive, and that means that the car is moving forward. The car is moving in the positive direction. And according to your situation, positive direction could be up or down or right or left. It depends on the situation. We can also find out the value of the velocity for the journey. Since the velocity is constant for the whole journey, instantaneous or average velocity will have the same value. So how do you find out the velocity? Well, you find it from the gradient of the graph, and for that you need 2 points. So let's say I'll pick this point and this point, and I can conclude that the change in the quantity y, y2 minus y1 is 50 minus 10 is going to be 40, and if you subtract the time from 5 and 1, you get 4. So 40 over 4 gives me 10 meters per second. That is the velocity of the car. Alright then, what about this situation? Well, again the points are plotted, but you can see that the displacement is not quite increasing steadily here. Again, the car starts from the starting from the 0. It starts at the starting point, and then it moves in the positive direction. So let's consider right as positive again, and we can see that as the car moves on, each second the displacement is increasing more and more, and we have plotted those points on the graph. So let's just join them all, and you can see that they are basically forming a curve, a smooth curve. And for a curve, the gradient is never constant, it's actually changing. Now the gradient is changing, which means velocity is changing. But how is the gradient changing? Well, if you look at this part of the graph and then compare it with this part of the graph, you can see that the later part is much steeper. So we can conclude that the gradient is increasing. Therefore, velocity is increasing. In the same way, we can also say that the gradient of this line is actually positive. The line is going up. So we can also conclude gradient is positive, which means that velocity is positive, as in the car is moving forward. It's never coming back to the starting point for these 5 seconds. Now, there are two pieces of information you can find from this graph. One is the average velocity for the whole journey or for any given range of time. So basically, I could tell you what is the average velocity of the car from 2 to 4 seconds or from 0 to 5 seconds. So let's find out the average velocity for 0 to 5 seconds. So from 0 seconds to 5 seconds. How would you do that? Well, we know that it's just total displacement over total time. So the car was here at the end of the journey, and at the beginning of the journey it was a 0. So total displacement is 150 and the total time is 5 seconds. That gives me 30 meters per second as the average velocity for this journey. What I can find out as well from this graph is the instantaneous velocity, which, if you remember, is the velocity or the speed at any given moment. And let's say I could ask you, what is the velocity at 3 seconds? How fast is the car going at that time? Now the speed of the car is always increasing, the velocity is always increasing. So for that, what you need to do is draw a tangent to the curve, and the tangent is gonna look something like this. It's a line which just touches the curve at one point. So we draw a line like this, a straight line which just touches the curve at one point, and we find the gradient of this white straight line, and that gradient would look something like this. Let's say I highlight this point and I pick this point, and by drawing a triangle, it's quite clear that I'll have to do some estimates here because my graph is not very accurate. I don't have a very big scale here, so I can just say that the change in the rise of this graph is around, I don't know, 130, and the run of this graph is 4.5 seconds. So 130 over 4.5 is going to give me 28.9 meters per second. That is the speed or the velocity of the car at 3 seconds at that particular moment. Now this tangent would be a little different for everyone when you draw it for a graph, and the values that you get from the answer will lie in a specific range. Not every student is going to get the same answer. So when you are required to draw a tangent in your paper, don't worry about being too accurate. Just do your best. Draw a line which just touches the curve and then find out the gradient. The procedure is actually more important than the final answer. Alright then, let's look at this graph. Once again, the car starts at the starting point and moves in the positive direction again. Now doesn't come back. The displacement is always increasing, but you can see it increases more in the beginning and then it's kind of slows down towards the end. So the graph actually looks something like this. What can we say about the gradient of this line? Well, if you pay attention to initial part of the graph, it's a steep line and then the line becomes flatter. So we can say that gradient is decreasing, which means that velocity is decreasing. We can also say that gradient is positive since the line is always going up, it's never coming down. So we can also say that velocity is positive, which is to say that the car is always moving forward, it's not coming back. And again, from this graph you can find out the average velocity and the instantaneous velocity by doing the same thing that we did in the previous graph. I think I made a slight mistake in the previous part. You can see that the final displacement, or the total displacement for the whole journey, was not 150, it was actually 125. So we need to recalculate this. 125 divided by 5 is actually going to give me 25 meters per second as the average speed for the whole journey. So I made a slight mistake here, and I think it would be the same for this one as well, because you can see that the whole displacement is 125 and you can divide it by 5, you'll get the same answer. But we know how to do that now. Let's look at some other shapes here. We don't have any data here, but let's say I give you a shape of the graph and let's try to describe how the car is actually moving. So we're just going to qualitatively describe what the car is doing in these situations rather than use actual numbers. So let's say I have a shape of a graph which looks like this. What does this tell me? Well, it tells me that the car actually starts 50 meters away from the starting point, and then since the gradient of the graph is negative, the car is actually coming towards the starting point, and it reaches the starting point at 5 seconds. I can also say here that it's a straight line, the gradient is constant, therefore the velocity of the car is constant. The velocity is negative, which means that the car is moving in the negative direction. Let's look at another graph. What if I give you this shape? What does this mean? Well, this means that the car again starts 50 meters away from the starting point, 50 meters to the right of the starting point, and then again it moves towards the starting point in the negative direction, since the gradient of this line is also negative. But since this is a curve, and you can see that the curve is steep initially and then it's much shallower later on. So what is happening to the gradient? The gradient is decreasing, which means that the velocity of the car is decreasing. The car is actually slowing down or decelerating when it's coming towards the starting point. Let's look at another graph. What if I give you a graph like this? What does this tell me? Well, this is telling me that the car starts 40 meters from the starting position and it's coming back to the starting position, but this time the situation is a little bit different. The graph is actually shallower in the beginning and much steeper towards the end. So that means that the gradient is actually increasing, and the gradient is negative again, so the car is moving in the opposite direction towards the starting point. The velocity of the car is increasing since the gradient of the graph is increasing, and it reaches the starting point at 5 seconds. Okay, now we have a graph which is a little bit different. What's happening here is that you also have negative axes here, and let's say I give you a graph which looks like this. Let me give you a graph which looks like this. Let's try and describe what's going on in this graph. Alright then, so what does this graph tell us? Well, first of all, it's a straight line, so we can say that the velocity is constant. Secondly, we can see that the gradient is negative, so the car is moving always towards the left, towards the in the negative direction. Thirdly, it tells us also about the position of the car, so it starts 40 meters from the starting point and we already know that the car is moving in the negative direction by looking at the negative gradient, and then it travels at a constant velocity and it goes past the starting point. It doesn't stop there, so it goes, and it doesn't stop at the starting point, but it goes past it, and it goes past the starting point at 4 seconds. That's when it crosses the 0 meter mark, and at 6 seconds it is actually 20 meters past the starting point, but all the time the car is traveling at a constant speed. Well, let's look at another situation. What if I give you a situation where the graph actually looks like this? Well then, what information can we extract from this graph about the motion of the car? First of all, we are looking at the graph is not a straight line at any point. I don't think so. It's basically a curve, and that's what I've tried to draw here. But what we do know is that the car starts at the starting point. So the car starts from here, and you can see initially the car moves forward. The car has a positive gradient, and let's say the car, you can see that this part of the graph is much steeper compared to this part. So what is actually happening here? Well, the gradient of the graph is decreasing, so the car moves in this direction and it slows down as it approaches the 3-second mark, and at 3 seconds the driver actually decides to stop and take a U-turn, and then you can see that the graph has a negative gradient, so the car is actually moving in the negative direction, and it comes back to the starting point at 6 seconds. At 6 seconds it crosses the starting point again, and then it goes past it. But what about the speed of the car when it's coming back? Well, if you look at this part of the graph, you can see the graph is much shallower when you compare the gradient to this and this part. So the graph becomes steeper and steeper as the graph goes on, which means that the car is actually speeding up when it's going past the starting point. Also, if you just pay attention to this part of the graph, what if I draw a tangent at this point at the very top of the graph? Well, the tangent at the top or the bottom of a graph always looks like this. It's always a line like this, which basically tells me that the car was at rest, or the car did stop when it was taking a U-turn when it was here. So again, just to reiterate, what are the rules that you need to remember for this graph? Well, it's just that the gradient of a graph is going to give you the speed or velocity depending on which type of graph it is, and how the gradient changes also tells us about how the velocity or the speed is changing, and the sign of the gradient, whether it's positive or negative, tells us whether the car is moving towards the starting point or away from the starting point. Alright then, I'll see you in the next video.